À tous EDD, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top.
I'm Michelle Doherty. I'm a professor of planetary physics at Imperial College in London. I'm also head of department at the moment. And on JUICE, I'm the magnetometer principal investigator.
I am Michel Blanc. I am a space plasma physicist specializing in the exploration of giant planets. It's really my passion, I would say. And I was the originator of the Laplace proposal that led to JUICE at the European Space Agency. And right now I'm also a co-I on the Juno mission, which is flying around Jupiter as we speak.
I was thinking the other day about how long I have been involved in JUICE, or the early incarnations of JUICE. And we first started thinking about a mission to Jupiter and its moons back in 2008.
NASA had been going to Jupiter. At that time also NASA was arriving at Saturn, so really exploring for the first time in depth with an orbiter this fantastic world. And after Saturn it was quite natural that ESA and NASA, who had already been working so well on going to Saturn and Titan, could do something together on Jupiter.
And originally it was a joint discussion between NASA and ESA scientists. And there were going to be two spacecraft. One was going to be built by ESA and would orbit around Ganymede, and the other would be built by NASA and orbit around Europa.
Then it was selected by ESA for the Phase 0 study, and we established with NASA a joint study group for a mission which for us was called EJSM Laplace. So on the American side, Europa Jupiter System Mission, which was in study at the time, and on the European side, Laplace.
And we came up with this mission plan, and we were about to present to ESA, and then NASA realized they couldn't afford to build the Europa orbiter. At that stage, I was the lead of the European side of the science definition team. And I remember being asked by ESA we were asked to come up with a European-only mission that we could do. And they said, you've got about 3 months to do it. And our hearts sank, because we thought, how can we do that in 3 months? But also they asked us to come up with a new name. And so we spent a very busy 3 months changing EJSM so it became JUICE. We kept most of the Ganymede ideas that we had had. And we came up with what I thought was a spectacular mission. We didn't have much time to come up with a new name. And so I remember what we did is we had a long day in the lab talking about what it was that we would try and do with the new sort of mission. And we were sitting in the pub. And I said, we've got to come up with a new name. And we had had 2 or 3 gin and tonics by then. And so we came up with a list of names because we knew that ESA would probably not like all of them. And one of them was JUICE. It wasn't the top name that we came up with, but we gave the list to ESA, and they focused on JUICE, and they said, yes, that's the name that we want. But they said, we'll probably change it once the mission's adopted. And, I think it's really appropriate because it covers Jupiter, covers the icy moons. You've got to concentrate a little to get the acronym out, but everyone now thinks of JUICE as JUICE, and I think if we change the name now, I don't think it's a good idea. So JUICE it is.
Back in 2010, I was invited to become a part of the team that was developing the scientific requirements for JUICE itself, or Laplace, or JGO, the Jupiter Ganymede Orbiter, as it was known at the time. And I was assisting as what's called an ESA study scientist to try to develop all of the definition of the mission. So what science it was required to do and how all the instruments would work together synergistically to accomplish that science. I study how Jupiter's atmosphere shifts and evolves and changes over long spans of time. And I do that via remote sensing. So what I want to do is have instrumentation that spans the electromagnetic spectrum all the way from the ultraviolet out to the microwave, because all of those different wavelength ranges, they tell you something different about the atmosphere of Jupiter. Today, I serve as one of 3 interdisciplinary scientists on the JUICE mission, overall tasked with trying to manage the Jupiter atmospheric science that we're going to be doing from this spacecraft in the 2030s.
What was in the basis of JUICE is that there was a discovery of oceans underneath the icy crust of the Jovian moons. And this triggered understanding or perception that life can emerge not only on the surface of a planet like it was on Earth or like we expect to be on Mars, but it can emerge in the deep oceans of the icy moons of the Jovian system. So basically the mission was designed to look for the geophysical conditions which are existing on those moons.
There is a huge diversity of planetary bodies while we are in the same planetary system. Io is a small moon with no ice, extremely dynamic. Europa is like Io, but you put an hydrosphere of 100 kilometers thick, and in which there is a liquid ocean, as far as we know, and in which the exobiological potential is huge. As far as we know, the icy surface is a few tens of thousands years old, no more. That means that it has been recycled many times, and it means that the moon by itself is very active due to the gravitational interaction with other moons and especially with Jupiter. Then you go further away and you have Ganymede, the biggest object in the Jovian system. The moon is slightly larger than the Mercury planet. You have an iron core, a thick silicate mantle, above which you put a huge hydrosphere which is made of few hundreds of kilometers of ice plus probably liquid water too. Ganymede is much less active, but still active as far as we know. But the activity is in the interior, because as far as we can see, the surface itself is a few hundreds of million years old. The youngest surface, because there is also old surfaces which are billions of years old. And then you go to Callisto, and there, the body has been in it for possibly billions of years. From what we can see, there has been no activity at all, which has been registered on the surface of the moon. When you get the big picture, you have the big panel of 4 moons, which are so extremely different in terms of composition, history, exobiological potential, geological activity, and so on and so on.
The scientists describe these are the open science questions. These are big themes. We would like to go there to resolve those questions. And this is the equipment that we need to bring with us. And this is the kind of mission that we're dreaming of. And this is done together with the agency, because agency here is investigating or studying those ideas, how they can fit into the technological capabilities of Europe and of the agency. And so this is the first phase.
JUICE is unique in various directions. So first of all, it's a mission which is relatively complete in terms of instrumentation on board. So we can cover all the science themes which the study team has put together in this so-called science matrix. But it's also unique in a sense that it will be the first mission ever to go into orbit around a moon of an outer planet, which is the moon Ganymede, and will investigate with all the instrumentation on board all aspects of science. We will arrive at the Jovian system together with a NASA spacecraft called Europa Clipper. So we will have also the opportunity to have the same 2-point measurements originally planned in the original Laplace proposal. You know, and this is where we go back to the very beginning of the proposal of such a mission, that we want to have multiple point measurements with 2 different spacecraft in the beginning. Then we had only 1 at the end, but now we have 2 missions at the same time, and we will be able to do these science, synergistic science, 2-point measurements, looking at the aurora while being on this field line, connecting these aurora with your location, you are on your spacecraft. And all these topics could not be done before, but now with JUICE and Clipper at the same time in the system, we will be able to do unprecedented science at Jupiter.
When the proposal is being investigated, the agency, European Space Agency, is putting a lot of efforts, creating teams that can really look into many aspects of the missions. Launch capabilities, the size of the spacecraft, the power which is needed, the transmission of data, how big the antenna should be, how powerful the transmitter should be, and many, many things like this. And of course, you understand, flying to Jupiter is not that we do every day. This is the first flight of ESA, of Europe. So that means that there are lots of technologies that need to be developed. So after this first round is done, we call this assessment phase. Basically, feasibility of the mission is assessed. And we, together with the scientists, they come to the conclusion that yes, it seems that it's possible. There are no showstoppers. Then we go to the next phase, the phase B, which is called definition. It is more engineering. So here we define interfaces. Here we define how different areas of the spacecraft or of the mission will interact with each other. Where do we put focuses? Where do we have potential issues? And so it's more careful scrutiny of all the elements of the mission. And after this is done, and when we have a conclusion that yes, the mission is well defined, we go to the implementation phase. Basically, we push all our considerations, ideas, everything to industry. And industry, with the big teams, they start really creating the spacecraft.
My name is Giuseppe Sarri, and I'm the project manager of JUICE. So I'm responsible of the mission, and which consists in three big elements. One is the element which fly, which is the spacecraft. Then we have to procure the launcher, because we need a rocket to launch it, and we have to develop and procure the ground segment. So all the infrastructure at ground that we need to have in order to operate the spacecraft when it is flying. The industrial phase, so the building of the spacecraft, started in July 2015, so it's 5 years ago. And we are at 2 years and a half, less than 2 years and a half from launch, because our launch date is May 2022. Like all the space program, JUICE is really a program which put together a lot of countries. This is a science program, therefore all the countries which are member of the European Space Agency, they will participate. So we are talking about 22 countries in Europe, but not only. We have contribution from the United States, contribution from Japan, from Israel. So it's really an international endeavor which is focused on European participation. Just to give an example, only for the industrial part, so not talking about the instrument, only for the industrial part, we have 83 different companies delivering hardware for JUICE. On top of that, we have a lot of scientific institutions, observatory, research center, National Space Agency, and those are providing the instrument. So it's really a work of the full Europe together. Our big challenge is the time. In fact, we cannot go straight to Jupiter because we would need a super powerful launcher which does not exist. So what we do, we fly by planet of the inner solar system, and particularly to Earth, Mars and Venus, in order to get at each flyby a little bit of energy from the planet. With that, the spacecraft will increase the speed. And after we have done that, we will have enough speed to get to Jupiter. However, since the planet are of course moving around the Sun, depending where we launch, we have good condition or bad condition. And in fact, the launch in May 2022 is the best opportunity because it will allow us to get to Jupiter in 7 years and a half. So for us, it's very important to be on time.
In the past 2 weeks, the number of cases of COVID-19 outside China has increased 13-fold, and the number of affected countries has tripled. There are now more than 118,000 cases in 114 countries, and 4,291 people have lost.
I'm in the team here, in the JUICE team, since 2014. We have split the tasks between Friedrichshafen and Toulouse. So Toulouse is a prime team, and they are responsible for the domains of mechanical, thermal, attitude and orbit control, AOCS we call it, and software. Airbus Friedrichshafen is responsible for the assembly of the spacecraft. So that is the main group of people in my team. And then we have electrical engineers working on electrical engineering and EMC, electromagnetic compatibility. And that is a very important topic in JUICE. And it's one of the strengths of this Friedrichshafen site. So we have specialists in these domains and a lot of experience and heritage from previous satellite projects. You mentioned COVID-19. Yes, we are trying to cope with this situation best possible. We have installed a special organization in our team to go in a two-shift modus, so with two teams. So we have a red and a blue team, which were separated in time and not meeting each other. The spacecraft came to here from Lambertshausen beginning of April. We had planned to have external companies here, Airbus Madrid, Airbus Poland, to do works on the spacecraft. So this was not possible, or only later on it was possible, but with a lot of limitations. So we tried to overcome this by taking over certain parts of the work of these companies. And yeah, in the end, we managed more or less to keep our goals and to stay in the schedule, but with a lot of over hours, let's say it like that.
It's a very interesting project. We have a very exciting topic and we have a straining schedule. So my start with the project began shortly before the COVID crisis, so it all started already, the work being a bit more difficult with the shift planning. We couldn't exchange so much in between shifts because we really had to separate the people. So this was a very strong experience, let's say like this. It is a multinational project, so it's a lot of working together with the colleagues in like Spain or with us, with the colleagues in Toulouse, French colleagues. So we have a lot of WebEx calls even before, just to understand and to discuss the problems we have. The main interesting points of JUICE, being a magnetic mission and putting these magnetic constraints on us, have been a challenge to discuss the tooling that we can use, that we have to be careful to not even go too close with the badge, things like that, or keys, or things that are not usually such a big problem. I had a warm welcome. In the mechanical team, I'm indeed the only woman, but in general, it's not a big difference to other projects. Here in Germany, we don't have so many women in engineering.
Today we film the integration of the optical bench, that is the bay when this is the cameras. This subassembly is 10 panels. In Madrid we pre-manufacture 10 panels and then assemble it together and then bring it here to Friedrichshafen and then mount it on the spacecraft.
Manuel, hasta que tú digas que está más cómodo por el brazo.
The last year I was here, I think almost a year. The first part in the Lamperhausen, and then now in this last part in Friedrichshafen. And also we will be here during the next month also. I involved with this mission near 5 years ago. We started with all the design, how to mount it, how to manufacture, was very special. And from this part until this is a big moment.
So welcome to the JUICE checkout. Here there are several places just in front of the window that is separating the checkout room from the clean room.
We got some delivery from the...
So here we have 2 computers that are directly connected to the spacecraft to run functional tests. In the functional test, what we do is to switch on the spacecraft and test that a unit is functionally doing what it's supposed to be doing.
I'm responsible for the onboard computer and of the software of the JUICE spacecraft. And the onboard computer is, let's say, particularly critical because it's where all the main functions of the spacecraft are executed. But the peculiarity of it is that it has to work seamlessly for something like 10 years. The onboard computer is made of basically two computers. One is always on and the other is off. So if something happens to the nominal computer, then the other one will be switched on to replace the function of the main one. Our spacecraft doesn't have a monitor or a keyboard to interact with. The only way to interact with the onboard computer is via telemetry and telecommands. You transmit telecommands via a radio frequency signal, which is received by the antenna of the spacecraft, and then it translated into data that are acquired by the onboard computer, and the onboard computer replies with telemetry, which is again data that are modulated into a radio frequency signal, which is transmitted to ground. When the spacecraft will reach Jupiter, it will be at something like 700 million kilometers from Earth. And the signal takes 40 minutes from Earth to reach the spacecraft. So we cannot rely on the operator on ground to take care of all the possible events or issues that might happen in flight, because it would take 40 minutes to send a telecommand and 40 minutes to get the telemetry back before actually the operator can actually be aware of what's going on, if a telecommand is not executed or if an event has been generated on board. So the spacecraft has to be capable of dealing with any unforeseen event, such that it will be able to stay safe, to protect, let's say, the equipment that are on board, and to be able always to be able to communicate with ground and to have the solar panel illuminated, such that the mission can be resumed if necessary.
To operate a spacecraft, you need energy, you need power. And normally we get power from the sun using solar array. But around Jupiter, there is not much sun. Therefore, the solar array has to be very big. Then all the stuff that we built there has to survive very low temperature. And the third one is that the environment around Jupiter is plenty of electron, proton, heavy ion coming from the sun, coming from deep space, coming from Jupiter itself, which are all collected around Jupiter by the magnetic field of Jupiter. And also to build electronics which can survive this radiation environment is very difficult. Now, each of the three things we can do, but putting the things together is really the challenge. That's why I think the solar array, which is very exposed, and put together these three difficult technology is really a great piece of engineering. Maybe a piece of art.
Ja? Ja, zeg maar. Tel maar op. 3, 2, 1, go. Ja, maar was het mis. 26 erin volgens mij. Ik zat daarnaast. En 1 seconde had jij, hè?
Today is quite an exciting moment for the JUICE Solar Array program, because we are performing the hot knife deployment of the first solar array wing, and that's quite interesting because it's the first deployment of the integrated wing, where we cut the actual restraint cables of the wing, like we're doing in orbit. There are some features to it, of course, because our JUICE Solar Array has an inline system and a lateral system, and on ground we can only deploy one system at a time. So we'll see today is only the inline deployment after release of the restraint cables.
Today we're going to Airbus the Netherlands, here in Leiden. We're going to look at the solar panels. It's very difficult, yes. So we have to work from home, which means even though Airbus the Netherlands is very close by, it's practically impossible for me to visit them. So I kind of miss the personal contact with the people, yeah. So today, by exception, we can go and have a look at the panels. But yeah. Well, despite all the difficulties, we still go on. I mean, the JUICE project has still managed to keep on track, so it's a great achievement so far.
Deze 4 nog helemaal bezet.
The solar panels are so large because there's about 25 to 30 times less light at Jupiter than here on Earth. So here on Earth, all the solar panels together would create around 30,000 watts. That's enough to power a whole street. At Jupiter, you can get like around 900 watts out of it. That's barely enough to have your hair dryer in the lowest position. So one panel, for example, at Jupiter can power a computer, and that's about it. So you see these wings, you see them on the video in a deployment, and you say, wow, that's impressive. When you are here and you see the deployment real life, you say, wow, this is huge, this is incredible. I'm happy to be here and having seen the solar panels in real life.
After 1 year of activity, after 1 year of COVID, the spacecraft is more than 80%, probably 90% in the final flight configuration. And this is a milestone which is important technically, but also psychologically, because the team see that an effort is paying off, that we have already the spacecraft to test. And then when arriving here, it will mark the start of 1 year-long test campaign. Now we will test the spacecraft to make sure that we can launch next year. COVID cost us 2 months and a half of delay, and therefore that make the launch in June basically not feasible anymore. And now we are working toward the target of a launch in September, which is the second window of opportunity. In fact, we have only 2 windows of opportunity per year. Today, the spacecraft will arrive. The transport will be with 5 trucks, which will arrive in 3 days. The first 4, they are carrying the mechanical and electrical ground support equipment. So all the hardware which is necessary to operate the spacecraft, but also to move the spacecraft in the clean room, because the spacecraft need to be stand vertical, then horizontal, then incline, depending which activity, which integration we have to do. And then the last one would be the spacecraft itself, and the spacecraft will be carried by a huge truck. I think it's 21 meter long and 5 meter wide, and the transport will last 3 days, in fact 3 nights, because the truck is so large that they cannot travel during the day.
We are hitting the road, meeting JUICE in Venlo in a few hours from now, and we'll accompany the spacecraft till ESTEC. I am the project scientist of the JUICE mission, so that means in the ESA project I'm taking care of all the scientific aspects of the mission. I am chairing what we call the science working team. So in this group we have 11 principal investigators. So that's the person who delivered the instrument to the JUICE project. We have also 3 interdisciplinary scientists which will look for connection and scientific connections between the topics and the instrument. So the core team, it's really 14 people. But behind that, every team is composed by a number of scientists. So if we count all the scientists in the teams, we arrive quickly to a number of 400 people. In Europe, in the US, we have a strong US participation. We have a strong contribution from Japan as well. So in fact, all around the world, we have scientists, something like 400. Official scientists of the mission. But if you count all the student, the PhD, the postdoc, and other people who are not formally part of a team, we can quickly end up with 1,000 people. So there is a big community behind the mission. We have a lot of expectations. We would like to get great data to do great science in 10-15 years from now. So we really have to build a good spacecraft and a good instrument to satisfy this big community. It will be a very important mission. I think we are ready to go. Let's meet JUICE.
Yeah, we are ready for the last stage, and at 4 in the morning we will arrive at ESTEC.
C'est très dur la nuit parce que ça demande beaucoup de préparation la journée avant le départ, et après la nuit il faut être concentré au maximum pour éviter la moindre erreur.
Ah yeah, I think I see the spacecraft. I see the big white truck. It's really an adventure to be here, to see the truck. I think it's an exceptional moment.
We have done a route survey in the week before of the transport to make sure that the spacecraft container can pass every highway bridge.
The security is going at the gate.
It's like expecting the delivery of a baby.
We are here in Nordwijk, and 3:30 working ends in this moment to prepare this transport together with my colleagues, with the full project team. Yeah, it's a great moment for me. Yeah, excellent.
Het is alsof je elke keer met een grote circus op reis gaat. En op sommige plekken moet je zelfs je eigen wc-papier nog meenemen. Maar niet hier, hoop ik. Nee, hier niet, nee. Nee, hier niet.
Animal, ¿tú sabes? We are going to pass through this cable and another one, so people don't stop stumbling with the cable every time they are walking in the checkout.
I see you. Very nice.
It's not direct to the Bodensee, but to drive a few kilometers.
Yes.
Only a few
Anna, is this this?
No, not the other one.
Directly at
The other one.
I see.
You see my hand? So you know whenever I can.
12 years in the Eifel.
I studied at Aix-la-Chapelle. He got, I think, a space of 1.50 meters, something like this, below the floor. So if you remove all the floor, we can make a swimming pool here inside this room.
I'm working here for JUICE project as a logistic manager, and my task is to look after every box and every single item, where it goes into Remco storage or to clean room or to the chamber. I have a list, and so I can check if the stuff is in which box. And otherwise, I have to check in my brain when the people say, I need an orange cable. Okay, I have to think about it. In which box could it be and what could it be? So I'm asking questions to the people, and then I get some information which I can use for the search in the packing list. In my free time, I also interested in astronomy. Yeah, so I have some colleagues also interested in astronomy, and I can talk with them about this project and what results are expected. Yeah, that's very nice.
Now we are starting the system environmental test, so it's the full spacecraft which will be tested. It's not only one subsystem or few units, but it's all together.
C'est pour ça.
Donc, dans ce sens-là que...
Savoir ce qu'il doit faire à travers nous, avec Ariane Espace.
C'est pour ça.
Well, colorful, beautiful.
You know how I like to make
Today is the first day when I'm not parked in the first row since Corona broke out. I'm in shock.
Right.
Yes,
It starts to be quite a few people.
It's getting more busy.
For late because of the
Okay.
holidays. Where's Giuseppe?
I don't know. Morning. Morning.
I'm in charge of all the documentation, which is a lot, and then all the office things around, like the missions, the office supplies, the social sites, everything. If it's non-technical, I'm usually involved.
Because we also need to.
Our office doors are always open, because we prefer to, walk around, talk to each other. Same with Giuseppe's office. He's very approachable, which is how we work, because there's no real boundaries or hierarchy. We just, it's a very open flow also for the information. So it's a very good atmosphere, I would say, yes. Hij heeft zijn badge al. You are launching a machine that has never been built before. Everything on it is new and invented. You have a very tight schedule from day one, basically. So of course there's gonna be stress. And of course there's gonna be, emotions and maybe disagreements. So if you are in a good relationship with each other, you don't let it become an argument, because you discuss it before it becomes an argument. And that's how I would like to think we also work with our PIs that are delivering the instruments. We invite them normally 2-3 times a year. We're all together. We show them the whole progress of the satellite. They're very involved. And it's not just for us an institute that delivers something. They are really part of the whole picture. And I would like to think that we treat everybody the same way and we are all equal. Yes, that's very important, I would say. For me personally, I've seen, I would say about 30,000 documents about it, but now I actually get to see it in real life. And you're like, oh my God, we actually did that. And it's crazy to think that huge machine is gonna go to Jupiter.
What we do is we start with empty satellite, and we just equip the satellite with all the instruments, starting from like the tiny sensors, like the sun sensors, up to the like a huge beast of the high gain antenna. And it's our responsibility to make sure that all the equipment finds its way into the satellite at the right location with the right orientation and precise alignment. I worked for about 10 years in the space transportation sector, so this is the area where we built all the stuff and the experiments for the space station. And I thought it might be a good idea to join a different project which goes even further away than the Earth's orbit. So, and JUICE is the excellent project for this. So going to the outer planet, to one of the outer planets, and exploring its moons, and being able to touch it and to being part of it, and contributing a little piece to the success of the mission, and feeling that trying to make the scientists who are involved in this project a little bit more happier. Some of the scientists you could actually meet, you could discover a little bit more about their instruments. You can ask them about how they work, what technology is behind, and what the achievements are they expect, what they measure. And so you get deeper and deeper into the satellite. You understood it more and more, and understood more the ambitions that drive the scientists to do this mission. And so you got deeper and deeper, and got more ambitious about what you're doing. It's not like just putting a screw somewhere. It's more like, oh, this is part of an instrument, and if you put the screw in the wrong way, then you may not get the right results, just simply speaking. But this is how I go every day to work, and see, wow, it's not just a bunch of hardware, it's really something living behind the project.
The instruments are built in different institutes all over the world. Europe, also the US, also in Israel, and some elements also in Japan. So in order to build these instruments, the money comes from the States, and there is no contract between us, the spacecraft, and the instruments. So all the work is done as a teamwork. There is no exchange of money or funds and so forth. So basically, each state has given the money for the instrument to be built, and we are there just to monitor that the program goes well and that all the interfaces to the spacecraft are implemented correctly and verified correctly before the instrument is delivered to the spacecraft.
Here we are in charge of operating the test facilities of the ESTEC Test Center, which is the largest test center in Europe. And in this particular case, I'm in charge of a JUICE test campaign, the TVTV test campaign, thermal test campaign, which is currently here. Our relationship with JUICE started more than 2 years ago. We have tested here some instruments, also some mechanical subsystems like the MacBoom. We have done vibration test on it, we have done deployment test on it, and now it's time to test the satellite on its flight configuration. The test we are doing here in the test center consists on a balanced thermal vacuum test in the large space simulator that we have here behind us. And the test in itself consists on simulating the space conditions on Earth. How do we do this? First, we need to make the vacuum in the chamber with removing all the air and particles by different means. Second, we need to reproduce this cold that we also have in space, this chill we have in space. In order to do that, the chamber is covered with some routes that circulate liquid nitrogen through them. This liquid nitrogen is very cold, like minus 180 degrees Celsius, and this allows the satellite to face the cold of space. And finally, we also want to simulate the heat of space due to the incidence of the sun on the satellite. To simulate the sun, what we have in the LSS is a set of 19 lamps, very powerful lamps that are reflected into a mirror, which is reconfigured in such a way that we simulate the actual conditions that the satellite will see while going to the closest parts of the mission in the solar system. In this case, in the flyby on Venus.
Today we are since 6 in the morning here on this, and a lot of parallel activities. We did QA inspections, we did MLI integration, multi-layer integrations, and we are doing electrical setup, dismounting, disconnection, and we are clarifying the way to the chamber. We have to go through several clean rooms to get there, and it's quite interesting all the time and very dynamic, and a lot of people you have to deal with.
Ich vollgelegt ist, ja, ne?
It's going well. It's going well. So we're currently removing the clamp band to be able to lift the satellite up from the vertical stand all the way up here and down over there into the chamber.
I had the feeling that I got connection with a product. I never had something like this before. I always had connections to people. Okay, this is normal. But I felt a warm feeling inside my stomach, and I felt how my heart is beating, and I was holding the lines while we were picking up the spacecraft from the below of the clean room to bring it upstairs to let it inside the large space simulator, LSS. So, and it was like I was holding something very special. inside my hands. And this was a very emotional moment for myself with JUICE. Yeah, we had every day new challenges and every day new possibilities and opportunities, and so I was developing my personality with it.
I'm not sure.
So if it is too high, what will happen then?
I think we will go down again, back to the floor, and have to remove the yellow sling to gain some more heat.
Ja, lass Frank das andere halten und gib mir das.
What is the...
Well, it depends what you're betting. Are you betting against it, or that it fits or not fits?
A full box of beer.
A full box of beer? For if it not fits? And
Probably.
I get a cappuccino that is fits.
Okay.
But a good one, huh?
A good one?
Yeah, with foam. You know? The real foam.
With foam and with some chocolate powder on top?
Sprinkles, yes, exactly. And a cookie.
And a cookie.
Exactly. Okay, deal.
Yeah, okay.
Yeah. The box of beer is Heineken, right?
Corona conform, yeah.
I'm getting nervous as well now. I see a little bit of water coming down now. Oh shit! I'm gonna lose a crate of beer to this bag.
It's a little underneath.
You have your...
Yes! Yes! Yes!
Okay, ready?
Yes!
Tu tournes comme ça. Là, il va mesurer un tilt selon X, mais tu le tournes selon Z.
It's 14, right?
15.
15. Because 15, 6, 2021.
We are preparing for what we call the dry run. So basically we are switching on the spacecraft in what is the kind of the configuration for the TBTV, so for the test. And then we start to check that all the thermistors and all our sensors are okay. We start first with an horizontal orientation of the spacecraft, so we verify that the readings are correct. Then we prepare the spacecraft in the same configuration that will be in one specific phase of the TBTV test, and we exercise the rotation of the spacecraft itself to see what is the result, what can we see, what can we measure, and this will give us also a reference for later.
It's like it is flying into space.
Then at some point we also switch on one of the lamp of the solar simulator, so this will be interesting as well, and yeah, a bit of check really in preparation of the start of the test itself.
On a project such as JUICE, there is several people on several groups for different domains such as harness, functional, mechanical, etc. So all those persons or group of persons are working on their subsystems or their domain, and my role is to have this all them working together on doing the coordination on technical point of view. So this is, let's say, part of my job as system engineer. On the TBTV, I had a specific role in addition, which was a deputy test manager, a campaign manager. So I was in charge of doing the coordination of the persons there as well with Jeffrey. Because the team was quite large. We had in total we had more than 120 people, different individuals, so it was quite large. And with the COVID conditions, it was quite challenging, but great experience. It was a dream actually to work on such a project like this. Kid dream. And speaking about kid dreams, let's say, I'm a Lego enthusiast, and here for on my professional work, let's say, I like to make the design, the model of the spacecraft on which I work on, and to share it also with my colleagues who likes as well those models. So I have a series of my models. It's like a small collection.
At the moment we are faced with a decision. It's an important one, to remove the foil before closing the lid. The foil is there for cleanliness reasons, and unfortunately the foil is too heavy. The foil can break, can fall on the spacecraft. It will be difficult to remove it when the lid is on top.
We had a decision to take which would impact negatively one of several aspects between, for example, a schedule or cleanliness or the team time hours and so many things like this. And of course everybody was pulling in his direction.
The lid was cleaned by ETS, so it's as it is as now. It's been cleaned and ready to move over the chamber. So
yes, but the mechanism is the most problematic part. You know, you generate particles during the moving action.
The mechanism is very different from a crane. Huh? It's not on top of the top lid. Huh? It's on the ground. It's a rail. Huh? So on the sides of the chamber. So there is no risk with the mechanism. Huh? So we had to calm down and take the right decision.
Okay, so that means we have the view factor of only the lid with the satellite itself, right?
That's correct. Yeah. And what we could do maybe is just to rotate the spacecraft to 90 degrees, that the HCA is not looking up.
No. It's not possible. No, it's not possible.
We cannot rotate.
But why? Why do we do that?
It's about
seriously. What is the risk? The risk, we have a top lid which was clean, which will roll very slowly, on which the mechanism are on the side. This is the risk of having some particle falling. The time we are discussing, particles are falling. So my proposal is, let's remove this foil slowly and delicately and without risk to having it falling on the spacecraft. And then we place the top lid on the top.
Exactly, I understand your point, but it's already there. The foil is already there. You will remove either now or you will remove when the lid is up. So there's a risk for both sides, right?
No, because
now, if it's heavy, you will have also the same risk.
No, because the access is very well now, and then it will be very poor afterwards. That's the risk. finally, the driver, let's say, was the human risks. So we had no, let's say, there is no way to take a decision with the human risk. So then at the end we took the good decision and we used also mitigation actions in order to avoid, for example, losing too much time or having risks for the hardware as well.
Bye bye.
We are ready, yeah. I'll take the shoes on this running.
And you need to sort out your priorities here, Giuseppe.
Yeah, I know. Right. So, I think we have to start with this one.
You start with this
Today we celebrate the birthday of Elma and the start of the TBTV test.
Also macht ja dann die Punkt, aber ich bin aus dem Basketball leider nicht aus ganz drum. Was? Das ist der ernst drum. Ja, gut gemacht.
Thank you so much.
Happy.
Currently, we're here. Right at the beginning.
Il y a une faute pour Enable, enfin un template Enable, un template Enable et M de 0,18 pour un multi-comptable.
Hello, sorry.
Hello.
That means we are now 60 and we will start pumping down, okay?
Right. Okay.
It's time to inform everybody that the pumping down is
Okay, guys, pumping down is starting now.
Now?
Now.
I was the quality representative for Airbus, and we were yesterday closing both doors of the chamber, first the upper one, then the 5 meters front door. So yeah, I was the last one to see it used before we see it again a few weeks after its first trip to space.
A strong one.
Yeah.
Very bright.
But maybe
But
the
I think
two
that
things.
the one that should be the support.
Yeah. And maybe the white thing are MLI reflection or I don't know.
I think.
No, I'm fine.
Ready?
We can go.
Yeah,
It's okay.
Okay,
so
let's go
finish
for the
my
ride.
setup.
Okay.
Yeah. See you there.
I was doing it every week for some time, for long years, for 20 years, now less.
Yeah, we try to do it regularly when the conditions are there. So, but today we do it again.
Just a special case, a special juicy case.
Okay, so let's go.
So it's a nice tour to do and close to work, it's fantastic.
And was very nice to do it together.
Yeah, and together at the same time you lose how far you go.
Hey, you used to do that mainly before the pandemic? But it's good to take a break from time to time during the day. So, but yes, we need to go back to that more often. It's amazing to think that Juice is just behind this door.
C'est relativement petit, elle est horizontale. We are going lower and lower in temperature. It's getting very, very cold, and we switch on several equipment. We have a phase which is called dynamic science operation phase, which is very dynamic, where we switch on all the instruments. And we see that some went very well, and in one or two cases we have some slight surprise which have no real impact on the continuation of the test itself. So we are, with respect to the test, we are even a bit earlier than planned. So we are in a good stage at the moment.
It's incredible, but seems that we are really at the end of this test. We had to work with the spacecraft every day, night and day. There were a lot of things that we were, I would not say not expecting, but we had to cope with. But everything was solved, and we didn't have any critical problem.
It's good to see it again.
We have learned a lot, and this is very interesting for us and for the mission. So yeah.
We were here both to monitor the spacecraft during all this phase where the spacecraft was on vacuum and sustained to extreme environment. At thermal side, we can say that the JUICE TBTV is successful. We have validated the thermal design of the spacecraft. We have validated the passive thermal control, meaning the radiators and the heat pipes, which allowed the units and the instruments to work below the maximum temperature limit. And we have validated the active thermal control, meaning we have demonstrated that the heating power installed is sufficient to maintain the temperature of the spacecraft above the minimum qualification limits.
And in fact, we have validated everything to cover the whole mission from Venus to Jupiter. So it is really a big achievement for us because it was also several years of preparation, and to see that it went well, especially also with the sunbeam for the last phase. It was really amazing to see how it works. I think it's really amazing to work on mission like that. I mean, when you look at the sky and you see Jupiter and you're just thinking, okay, we go there, it's incredible. For me, it's really it's really challenging, and I think yes, the whole team is also amazing. So it's really nice to work with also a lot of people involved as you are in this project. Yeah.
Yes, I feel every day very lucky to be part of this project. And when I see JUICE in the LSS, I imagine it in the space and running to Jupiter. It's wonderful.
The spacecraft today is still in the chamber. Will be removed from the chamber. There will be inspection.
then it will be installed in the transport container. This takes some time because all the activities are very complex. And we will transport to Toulouse with an Antonov flight, and it shall arrive in Toulouse on the 10th of August.
I'm absolutely happy that we are on the road. It was again a long time of preparation, but in this case we have only 3 months. This was a shorter preparation time between start of the LSS and here in the moment when we drive to Cologne-Bonn Airport with the JUICE spacecraft.
Well, it feels just great. It is a fantastic moment for us and for me as project manager to see JUICE finally arriving here in Toulouse. We have a project will continue for a year. It is really fantastic. It is a moment we have been waiting for quite a lot of time, and we have been working very hard to prepare it. It feels really great.
So now we will see in the movie why this program is accumulating delay, because the project team is spending all the time drinking coffee. We have missed the launch opportunity that we had in September this year. The key reasons are further delay of few instruments, or the latest instrument, a couple of problems on platform equipment, that we have to remove the platform equipment and repair them. And then the COVID. In 2021, the COVID was as difficult as in 2020, so we continually lose time because people was sick, people was not available, and so forth. So we missed the launch date. We didn't miss much, couple of months, but if you miss the launch window, you are gone. And therefore, we have now a new baseline, a backup launch date in 2023.
Surtout avec la courbe qui I work on JUICE since quite a long time, actually, since 16 years now, and I'm what we call the mission analysis lead. Mission analysis is, I would say, the art of computing and designing trajectories. So basically, as input, we have the science team that will come to us with objectives like visiting Ganymede, being at that altitude, or going to Europa, and these kind of things. And then we need to design a full trajectory answering all these scientific goals.
On JUICE, I was a PI for 10 years, so I have a direct understanding of what was really important for science. And I could talk to Arnaud and talk to the science team and tell them, okay, let's put together what are the basics, what are the 3 pillars. And we ended up with a high inclination phase, 2 flybys of Europa, and foremost, this circular orbit around Ganymede, at most at 500 km altitude.
When the mission was adopted in 2015, the launch date was planned for 2022. And it nearly never changed. And we had I would say, a database of options for 2022, 23, 24, 25 that we established 10 years ago. And because we had that reference and everything looked very stable, we didn't make any further analysis. And then suddenly, a few months ago, the project understood that we couldn't make it in 2022. So we had urgently to find something new in 2023. In 23, we had 3 options, 1 in April and 2 in August. We wanted to use the 1 in April. The drawback of the 1 in April that we had was that it was very long in terms of transfer time to Jupiter. But at the same time, Yves had done some analysis and came to us and said, on top of these options that we derived 10 years ago and that we use as reference, there might be another one that would live in April and that whose duration would be shorter than the one we have in the database.
I decided to look whether we could have something earlier. And this is where I found this idea of launching in the equator while it is close to the ecliptic, which is the orbit plane of the Earth, which is unusual. It's not part of the normal way of looking at opportunities. So it's not surprising it was not found, but the story doesn't stop at being able to say, hey, there is something which could work, because the devil can be in many, many, many details.
When you design a trajectory, there are essentially 2 main steps. The first one is what we call finding the first guess, which is, I don't know, I mean, you want to go from here, Darmstadt, and you want to go to Toulouse, you just put the main milestones to Toulouse. But then you have a second step, where we call that refinement, and you start zooming in and trying to see exactly where do you go. You put all the perturbations that you're going to have in the model for the dynamics, and you take all the effects into account, and you really start consolidating that.
My idea was not enough. It really needed a lot of consolidation. As Giuseppe Sarri was saying, I proposed the idea and Arnaud and his team made it real. And the official validation of a launch opportunity that has to be done by ESA because ESA is in charge of the project.
We have now a launch date in April 23 with a window of opening on the 5th of April and closing on the 25th of April.
Prenez la deuxième sortie.
For me, the car is the moment where you're alone, can put the music at low volume and sing and let yourself go. Maybe it's part of the setting, I don't know. Oh, I have to go here with it.
Restez à droite.
We started coming to Toulouse as soon as we kicked off the contract with Airbus. So every year we're coming a few times already. And apart from the pause with the COVID, about 2 years we did only remotely.
Now restez à gauche.
We started coming more often because now the spacecraft is in the final phase of integration, and we start with the test campaign. And now this is already the 3rd week that I'm coming in a row because I'm following up the preparation for the electromagnetic compatibility test. So with some colleagues, we are working a shift. So we have to be here to follow the test.
Today is a very important day for many reasons. First, we are on the 5th of April today, so we are exactly 1 year to launch. We will launch next year in 365 days from Ariane 5 in Kourou, so that's a very important milestone for us. And it is also the start, actually we started yesterday, of a very important test for the spacecraft, which is the radiated EMC test. So basically we have assemble everything on the spacecraft over the last months, and we start again a new test sequence for the next months until shipment of the spacecraft to Kourou. We have done many things since arrival of the spacecraft in August last year. and in particular we had to reopen completely the spacecraft to remove a couple of pieces of equipment that were in anomaly or sometimes even in failure that we have discovered in the thermal vacuum test at ESTEC last summer. And so a lot of things to be removed, repaired and installed again on the spacecraft. And of course all the instruments, flight models that we were missing last summer have been installed over fall and winter last year to be now in full flight configuration for this test that we have started now.
Here in Toulouse, they are really used to have a lot of different spacecraft, especially for telecom satellites. So JUICE is a bit different because it's a science mission, interplanetary science mission. So also we had to adapt the different processes. So they have of course a kind of a serial production for telecom. So this is different from the single model that we build, because of course JUICE will be only one protoflight model. So some difference, something to be adapted, something to be learned, and something also to share, and different approaches to be merged together to have the best that we can really continue on this mission.
I'm one of the JUICE payload engineers. So that means that within a group, the payload group, a number of payload engineers follow specific instruments in JUICE. I'm following the instruments involved in RIME, which is the ground penetrating radar, and we have 3GM, which is a radio-sized instrument, and that contains ultra-stable oscillator, a K-band transponder, and now also a highly accurate accelerometer. My father came in '68 to the Netherlands to join ESA, which was in its infancy. So he was one of the first people joining here. So since I can remember, I was already coming here and very familiar with ESTEC as a place to come, and it definitely influenced my choices for my studies and everything to come here. You still hear, if people explain what is ESA, they say the European NASA. So it's a fact that the visibility of ESA isn't as obvious as NASA, but we are improving. We're improving. I think Rosetta was a very good example, where we got a lot of attention, a lot of exposure, and I think it's the trend of the agency also recognizing that in the end what we do is financed by European member states, so we also need to show them what we are doing and also to understand why things are so challenging. And I think with JUICE now, also part of what we're doing now, also these interviews and what's being posted on the web, I think it's part of explaining why things are complex. From the moment you start building it to the launch, it can take almost 10 years or more, depending on the mission. It's because everything we do, you can do before you launch. After launch, it's gone. So you have to check everything. You have to make sure that everything works. And only when everything is checked out and you're convinced, then you start. But once it goes up, that's it. You can never change anything, especially interplanetary, where it really leaves, and that's it.
Here we are in MDS facility. Here the goal is to recreate the vibrations and the noise that will occur during the launch of JUICE.
For this particular test, we have particular attention of the dynamic behavior of the spacecraft, because for the time being we have built some mathematical model, and we verify that the spacecraft reply as per predicted by the mathematical model. Then we verify that the response of the spacecraft is within the range we have specified and qualified at subsystem level. We are very satisfied with its behavior, which is quieter than expected initially by our mathematical model calculation. And according to the final success, we think that we can achieve it without too strong effort.
People to be able to go to the gas station and not see you.
JUICE has to measure, once we will be in Jupiter, very faint magnetic fields from the giant and from the moons. Therefore, it has on board a set of magnetometers which are extremely sensitive. And for that, we have to make sure that the spacecraft is extremely clean magnetically wise.
This is our facility for measuring the magnetic emissions in time domain, so the changing magnetic fields of all the units built into JUICE. We have several sensors arranged around the unit we want to measure, and then we capture the time profiles of the magnetic emissions, and the requirements are such that the cutting-edge scientific instruments integrated on JUICE are not disturbed by the spacecraft, and the emissions should be even lower. And this in the clean environment of free space, and the question is, how do we verify this on Earth? And in order to do this with off-the-shelf equipment, we use a trick, which is the extrapolation. So we measure much closer to the units, and then we can extrapolate and even verify these harsh requirements. We were very lucky that right after developing this new facility, JUICE was the first customer in order to apply these methods.
In August, we made a test in the clean room in Airbus in Toulouse, where a set of different type of magnetometers that were set around the spacecraft to capture all the possible disturbances while the spacecraft was working. This type of test at spacecraft level had never been executed before. And it was fantastic because it really worked extremely well. And what we discovered as well is that the spacecraft is extremely magnetically clean. It was 1 week of very hard work. It was really, really intense. But we worked so well all together like a single team that we had really beautiful results. Really, it was really amazing. It was mind-blowing.
Today is a great day. The spacecraft has been completed and the spacecraft will be shipped on the 8th of February to Kourou, and therefore we thought that was a good moment to do a step back altogether and to think about what we have done and how successful it was so far. We have made a tribute to Galileo Galilei. He pointed the telescope to Jupiter. He discovered the 4 moons, 3 of which are the moon where we are going, Europa, Ganymede and Callisto. So we decided as a tribute to him to engrave on a large piece of thermoblanket 3 pages of his book, the Sidereus Nuncius, where he recorded this finding.
In today's science, we take everything for granted. There is little in our work that makes us rethink to what Galileo did in the past. Sending some pages of the Sidereus Nuncius at Jupiter is a tribute to what he meant to humankind. Reading those pages, the astonishment with which he noted the position of these little tiny stars moving from day to day around Jupiter and showing the existence of a mini solar system within our solar system. It was not called in this way, of course, at that time. Is something really fascinating. And the importance of that discovery also is that it put men and women in a different position in the universe. It shifted them from the center of the universe to the right place. or it was at least the beginning of this shifting. Today we know a lot more, but it was a crucial step toward this understanding.
Und es befinden sich die Magnetometerinstrumente.
We have installed the second SLI effectively, on which we have engraved the names of the people from Airbus, ESA, the scientific community, the lead funding agencies who have contributed to the development of this amazing mission.
At the end of the development phase, the responsibility is transferred over to the science department and operation, and we will be conducting the daily operations and the science operation at the Jupiter system. This is the first time I see it in a final configuration, so this is really a turning point for me to see this amazing machine that Airbus and ESA have built together, and which will be hopefully my friend for the next decade also.
Today, as we speak, we are doing what we call the countdown rehearsal, so that's the first trial of the final launch chronology that we do in order to test this very important phase for the launch of JUICE.
I've never been to Peru and never been to South America, so it will be pretty impressive, I'm sure. Especially to just see the rocket live. It's like a dream come true. The job makes you, of course, travel a lot, and it's a job that people tend to do while they are young. But this, of course, makes it more fun for me because people are more or less my age, so we also do stuff in our private time. Actually, most of us are also friends privately, and that, yeah, I think if you travel a lot and you're on campaigns a lot, this is a crucial part of still enjoying your life, because you will be spending a lot of time with those people if you're working in AIT. The thing that made also JUICE for me so interesting to have this big international team where everyone really adds on their own perspective, and it really is what makes it fun. Like working together with the people and everyone putting in their knowledge, and then together you really feel like you can do great stuff.
We just left the airport of Cayenne. We passed the city of Cayenne, and now we are heading to Kourou, where is the Centre Spatial Guyanais, the CSG, when we are going to start our launch campaign soon as the spacecraft arrives.
Welcome to Kourou!
Today I'm here to witness and wait the Antonov landing that is carrying JUICE here in French Guiana to head after to the Centre Spatial for starting the launch campaign and all preparation activity. So it's big excitement today because finally the spacecraft is arriving, so there's no way back.
Hi, my name is Johannes Tumpinger. I'm a PA engineer on the JUICE project in the ESA team, and we've just landed here in Kourou in French Guiana. And yeah, we have had a good flight here from Toulouse. So yeah, we're ready to offload the spacecraft and start the activities here.
We're switching on the spacecraft for the first time in Kourou. So yeah, you can see in the background the lamp is on. The spacecraft is alive. We've seen the first telemetry, so it looks good so far, but of course we have to wait the end of the switch on to be sure.
No. There is still charged.
You see there's no current.
It's a major moment, yes. We're starting now, let's say, 2 months before the launch, and yeah, it's the start, and we are really looking forward for the rest of the operation to be ready for the launch.
Okay, nothing to add. I flashed them as good as I could.
Today we are here to witness our rocket coming out from the bill, Bâtiment Intégration Lanceur, and going to the BAF, Bâtiment Assemblage Final. On the 1st of April, our spacecraft will also arrive and the mating will take place.
To think that this is gonna go up to Jupiter for a 9-year journey after working on it actually for 9 years. I don't think I can find the words for that. I cannot.
So when you launch a spacecraft, you put a logo on the fairing of the launcher. The fairing is the nose of the launcher that encapsulates the spacecraft, that opens up once the spacecraft is in space and continues its journey. And since for us JUICE is very special, we had to create a special logo. Many children dream to be explorers when they grow up. And what a fantastic explorer can be JUICE. Exploring this mysterious icy moon around this gas giant, which is Jupiter, and going to look for the condition to sustain life. If life one day will be discovered in one of these icy moons, it will be our children to discover it. So we wanted to see how JUICE is seen through the eyes of the children. We launched the JUICE Up Your Rocket competition, open to all the children of the world. The response was overwhelming. We received over 2,600 entries from 63 different countries. It was such a commotion to see how far our mission has reached across the world and how well the children had picked it up. How to select the one among all these beautiful, representative and genuine entries. We had several rounds of reviews, and besides selecting the one that will go on the fairing, we selected also further 12 beautiful artworks that will constitute the calendar of JUICE, plus one additional special mention.
407
We should
from
keep it down
Switzerland.
for the next round.
Yes.
Yeah, this is in fact, from my perspective, is one of the 12.
This one I find so cute.
This one we keep it, huh?
Yes, we have to keep this one.
Yeah, this is really cute.
Isn't
This
it?
is really cute.
So sweet.
So we keep 24, 27.
It's still moving a bit. It takes very long.
Oh my god. Oh my god. Say goodbye to Juice. Bye, Juice. Please leave the last time. Bye. Oh my god. Don't cry, please.
So both the launcher and the spacecraft are ready. On Saturday we had the launch readiness review, and the fact that now we are ready for the rollout, it's proof that we are in a good status from launcher point of view. The spacecraft as well is ready. Last week Thursday we had what we call the dress rehearsal, that is the final repetition of the launcher chronology to be sure that everything is ready on spacecraft side and mission control center side and ESOC. Also everything well, the team are ready, the procedures are ready, and really it's really time to go for the real launch day.
I'm the system engineering manager of JUICE, which implies that I'm busy with overview of the engineering side. I'm also involved with operations, particularly with the science operations and with the spacecraft operations team at ESOC. I'm trying to feed these teams with information which I consider is relevant for them, such that they can better prepare their operations phase.
Can relax and enjoy.
Very, very excited. Yes,
yes,
I'm
we are.
very, very happy and very honored as well. Yes.
That's it. Happy to be there together, by the way.
Yes,
we have got so many things to do together.
There's a lot of nervous energy here in the room at the moment. Everyone's excited, I think a little bit dazed. We keep looking at our watches, making sure that we're not missing the big moment, but I presume someone's going to tell us that the JUICE is finally launched.
It will be announced, for sure.
It will be announced, I'm sure it will.
Today, on April 13th, 2023, we launch Europe's first science mission to Jupiter, the oldest planet in our solar system. Now, ESA's mission is called JUICE, so you can probably imagine why I have this cocktail in my hand, but more about that later. In his book called Fastes, the ancient Roman writer Publius Ovidius Naso, not NASA, Naso, writes that April 13th, that's today, is the day of the sacring of Jupiter's temple. So it's very prudent of the European Space Agency to select this day for a launch. Now we will move from drinking to drawing. And here she is. Welcome, Irina. Congratulations for winning first prize at the JUICE Art Competition. So you were 8 years old when you painted this this drawing, and now you're 10. At what age did you start getting interested in spaceflight and the cosmos?
I come from Zhytomyr in Ukraine, where Serhiy Korolyov was born, the first rocket designer. Our city has a wonderful cosmonautics museum. I used to go to the museum almost every week. I was inspired by astronauts and been interested in space. I often drew space stories and built models of satellites.
That's so cool. Now, I've also heard that you started drawing way before you started walking. And your picture does show a lot of professionalism. Can you tell us a bit about what your painting shows?
I want to portray and give human image of the Earth, Jupiter and its satellite. Each of the satellite of Jupiter has its own character. Europa peek out from behind Jupiter, Ganymede looks surprised and Callisto sleep. My pictures show that Earth and Jupiter are friends and wants to play together. Earth gives Jupiter a toy of satellite and he become friends and play. My planet have human face because space have a soul and a character.
That is wonderful, and it is an amazing painting. Thank you so much, Irina. We are now less than 10 minutes prior to liftoff. So let's go live to French Guiana and follow the final sequences of the countdown and watch the Ariane 5 ascent, followed by the first half of the flight. All of this produced, explained, and shown by the launch service provider Arianespace. All right, ladies and gentlemen, I've just heard from our event director that we have some information about the JUICE launch that we would like to share with you. And for that, I would like to welcome on stage Fabio Favata.
Thank you, and I'm really sorry to announce that while all the human things that we can control are green and great, the weather is not cooperating. And as you can see, the sky in Kourou is not particularly blue, which means there is lightning in the region, and therefore, out of safety considerations, Arianespace has postponed the launch to the next window tomorrow.
Disappointment, of course. We found out via Twitter that it had been scrubbed for today, but earthbound weather gets in the way of visiting Jupiter's weather once again.
Yeah, big surprise. I thought everything was green, and then they checked the weather. Big surprise. Well, it's only a postponement to tomorrow, so let's wait for tomorrow. But I was really hoping for today.
Well, you know, it's life in space. We have to wait for the best. I'm sure tomorrow will be good, or the day after.
The guys were already saying it, right? Like, after all this time, like, one day is not so much. We were eager to celebrate, but we will celebrate tomorrow then at home.
Exactly. And tomorrow is Friday, so even better.
So right now we're in the project support room. Behind that wall we have the mission control room, where we have the mission control team from ESOC. They are the ones that can interface with the spacecraft and send commands to the spacecraft. So in this room we have a team of colleagues from Airbus, from the prime contractor, and from the ESA team. In each station we have one person from Airbus, one person from ESA, and what we do here is we are monitoring all the telemetry from the spacecraft, and we are supporting the mission control team. So in case they have any question, anything that is not nominal, or anything that they don't have the time to check in real time, we can help them from here and help them to make decisions and to take whatever action they need to take. So we have here a station for propulsion. We have Steve from Airbus and myself. Then one for thermal. We have Romain and Séverine. One for power. We have Manfred and Sam. Here we have Ronan, that is monitoring all the deployable appendages. Then attitude control, where we have Jonathan and Pascal. Then we have onboard software and avionics. We have Luc and Florent. Here we have Eric, who is the team leader, who is the one that communicates with the mission control team. And then the last one is communications. We have Robert and Davide. as I said, in each station, always one ESA person and one Airbus person.
The whole beginning to end, actually. It's one of the few we were
All stations, this is Odi on the briefing loop for the roll call. Please reply on my call with your call sign and your status go no go. OM. OM. Go. Some go. Data handling. Data handling go. AOCS. AOCS go. Platform. Platform go. Flight Dynamics. Flight Dynamics go. Project Rep. Project Rep go. Project Support. Project Support go. Softcode. Softcode go. Software Support. Software Support go. S-Track. S-Track go. Scheduling. Scheduling go. Thanks. This completes the roll call for the JUICE mission. We are go for launch.
À tous EDV, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage EAP, décollage. La propulsion est nominale. Séparation JUICE confirmée.
And this has been confirmed that the spacecraft is safely separated on its targeted orbit. And you can see on the images the relief from the teammates.
This is years and years of work on the part of these teams.
Decades of works for some teams.
Yes. And it is so good to see such joy on their faces.
No,
of course, a reminder that this is the very, very first leg of JUICE's journey.
You can see the emotions on the faces. That's really what makes space activities so special.
So if JUICE is up there and it's transmitting to us, we'll see it. So as soon as JUICE gets its act together and gets its attitude stabilised and starts talking to us, we'll definitely hear that signal.
Yeah, JUICE is keeping us all guessing at the moment. So how long can this dish actually track JUICE for? Is it for the whole day, or how does that work?
Yeah, so our nominal mission tonight will be about 7 hours from AOS right the way through to what we call LOS, loss of signal. So we'll track up into the sky up to about 50 degrees, and then while we're doing that, JUICE is moving away from the planet and the planet's rotating underneath JUICE. So it'll actually come up, and rather than going over the other side like a normal satellite that's in Earth's orbit would do, it'll actually go up and then come back down as the spacecraft moves away and as the Earth rotates underneath. So we'll see, if you're still watching in 7 hours, which I'm sure you won't, we'll see the antenna set again, pretty much back where we came from.
Yes, Susie, I've got some great news for you. We have acquisition of signal.
We have telemetry flowing in the system. EMS, OD, we have AOS, and we see telemetry flowing into the system. OD,
has clearly happened, but I would have expected latch.
There we go.
Yes.
I proceed to show you the design of Flash by Week.
We are missing one. Yes.
Yeah.
See it?
Yeah.
So
we were very complimentary.
It's been a great ride.
Do it again.
Yeah, there is a mission, so we are really excited and also relieved because, yeah, the solar array deployed and we got telemetry and so on.
Now we are on the way to Jupiter, and everything has to be done to take the science that we expect from this wonderful mission, which is just now on its way.